Okay, so good afternoon. You haven't met me yet. Well, you have, but a couple of you have. My name's Don Burks. I'm head instructor for Web. Unfortunately, I couldn't be here yesterday because I was in Charlottetown doing a workshop for teachers, and I got in at 2 o'clock this morning, so I'm looking and feeling my best today. That's why I didn't do your lecture this morning. Um, I'll do the quick bit of intro, the Lighthouse intro. I've got 20 years as a web dev. I actually started off with a degree in music. I'm entirely self-taught as a programmer, but I've worked for companies like Microsoft, MetroLyrics.com. I've done about a dozen startups as either founder or employee number one. So I'm kind of the definition of not my first rodeo. My quirky fact that I'll give you is related to my travels, actually. So Lighthouse has been working with the federal government to deliver workshops for teachers all across the country on how to bring computational thinking and coding into the classroom. And I was one of the lead instructors on that, which meant that I've done a lot of travel. So last night was my 46th and 47th flights of the year. So yeah, thanks, Steve. Uh, so yeah, the frequent flyer miles are racking up, which is kind of the good thing there. You'll find over time that I end up having a lot of quirks, so trying to pick one is a little bit ridiculous. But today, we want to talk about reading code and scopes in JavaScript. And very specifically, I want to set this up and give you some context because there's a different part of your brain that ends up getting triggered when you, as a dev, sit down and you're just looking at code. For some of you, that part probably aches right now a little bit, but that's okay. Interesting fact, scientists theorize, doctors have proven that when we read code, that it's actually the language center of our brain that's getting triggered. And very specifically, it's the part that we use when we do silent reading. So if you've ever just been sitting there reading a book to yourself and you have that whole imagination, inner monologue going on, that's the voice of reading whatever's on the page, that's the actual part of your brain that gets used when you read code. The challenge is that we fall into a trap with that, which is when we as human beings sit down, we open up a book, we start reading the text, we read top to bottom, left to right, every line. And you can't read code that way. It doesn't work that way. And that means you have to approach it very differently. It means that you have to guard against a couple bits of bias that our brains give us. So I've got a couple of quick examples here. Let me get this zoomed in enough. No, it's too big. There we go. So, I want you to take a minute and I want you to look at this. And then what I'm going to ask is what is going to be output and in what order? So let's make a prediction. What do we think the first thing that's going to be output is? Yeah. All right. Good place to start. What's next? Somebody else. Yeah. Prediction there is C semicolon 0. Okay. Okay. B and undefined. And that pretty much covers all of our letters. Oh, we do have an E at the bottom. My apologies, I didn't zoom out far enough. Let's just assume that we know E is going to be last. And what do we think E is going to be at that point? 0, 1, rabbits? 0? Okay. I heard a 0, so we're going to go with that. Okay, so this is our prediction. And we will compare that with what actually happens when we run this. So keep this in mind, because that's what we predicted. Now let's work on getting those two to match. So, now we can see everything. Very first line of code that's going to get addressed is var x equals 0. That's initializes that variable, and that's the first thing. And it is definitely common practice for us to put variable definitions up at the top of our code. The best practice is to define your variables before you're going to access them. And if we always do that, we're always going to be in good shape. So the second line of code that's going to get executed is line 4. So for the console.log, we're going to output a colon, whatever the value of x is, and x is 0 at that point. Now when I as a dev and I'm reading this, I'm going to read down and I'm going to get to line 6 here. And when I get to line 6, I'm going to see that it's a function definition. And honestly, I'm going to skip over that. I'm going to find the closing parentheses of that down here on line 14. And I'm going to skip right over that because I don't need to know what's inside that function until I know that that function is getting called. Until then, whatever code is in there is its own thing. That's for later. So that means that I know the function is defined. I know there is a function named a that I can call at some point. But for me, I'm much more interested in the fact that the very next line of code that's going to get run is line 17, which is console.log. So I know that d is going to get output, and I know that the current value of x is going to get output. Well, x hasn't changed. All I've done is console.logged it once, so d is going to still be 0. Now I see that I'm calling the function a. I know I'm calling the function a because I see text immediately followed by parentheses. In JavaScript, that's a function 100% of the time. So I know that I'm calling a, and I am passing in as an argument the value of x. Cool. Now I'm going to go up and I'm going to look at this function. Now I care what's happening. Because if I go into it and start reading it now beforehand, I'm going to get confused. So I can see here that there's a parameter defined named x. Cool. So I know that that value is going to get passed in, and this is a local variable that only exists inside this function. Doesn't matter if it has the same name. It only exists inside this function. So right now, this is 0. So then b is going to get output next. So I've had a, I've had d, then I've had b. Then we're going to output the variable x, which is this one here. And so that's still going to be 0. We're going to take x, and we're going to increment it by 1. This will change the value stored in x. So that means when I log out console.log c, x goes up by, I know that x has gone up by 1, so c is 1. I'm at the end of the function, therefore my brain jumps back down to here. And console.log e with the current value of x, and this scope is still this one up here, not the other one. So we're back to 0. C is the only one that would show as 1, and that matches what we saw here: A, D, B, C, E. So a couple of pointers there. When you see a function, you don't need to know what's going on inside that function until you know it's being called. Because before then, anything that might be in there, variable names, increment values, other function calls that are going to happen, they may end up just muddying the waters and confusing you. Focus on the order of execution. Let's look at a slightly different example. Similar idea, but slightly different example. And Now that we've been through the previous exercise, looking at this one now looks a little bit different. Now we can start to use those same tools to predict what's going to happen. So what's the first line that's going to output? Bingo. Then I'm going to see this function a. I'm going to skip right over it. That means line 15 here, this is the next line that's going to output. That's going to be d, x is still 0. Then I see x plus plus. I know that my value of x has gone up. And this line is different than what we had before. We're calling the function a. We're passing the current value of x into it. X is currently 1. So we're going to call a. This is going to be 1, so we're going to get b1. So we have a0, d0, b1. We're going to increment this x, which is a different x, and log out console.log c, current value of x, which is going to be 2. So a0, d0, b1, c2. And this time our function returns something. It didn't before. So we're going to return whatever the value of x is, which brings me back down to line 19. I basically have to bookmark in my brain that this function was called on line 19, and because it's returning something, I need to go back to that point. And I'm taking what this function returns and storing it in x. So if this x is 2 at this point, and I return it, this x is now 2. So I increment x again. X is now 3. And I get E3. So we should have A0, D0, B1, C2, E3. Anybody have a different opinion? Speak now, forever hold your peace. Okay. This is that lovely teaching moment where everybody's like, he said it was okay. There we go. So it's a different way of reading. We don't do the top down, left to right. We have to like place mental bookmarks in our head and follow those through and be able to jump back and forth in the code in order to understand the order of execution. So, one that's a little bit more convoluted. And it's just because we are dealing with scope. This one I can blow up a bit. There we go. So my challenge to you is, what is going to be output on line 5 and on line 12? Bless you. I was allergic to JavaScript when I first started too. It goes away. You build up a tolerance. It's like drinking. Who's feeling particularly bold this afternoon? 5 and 12, the two that actually give us output. Okay. I will accept that as answer number 1. Does anybody want to give me a different answer? That's the subtle way of saying he's not quite right. Zero and 8. Okay, that's answer B. Does anybody want to give me another answer? It's my subtle way of saying that neither one of those is right. Aha. Answer C starts to win virtual cookies. Pretend I always have a stack of virtual cookies on my lectern so that I can give them away. So if we track this through, we start with line 1, we see it's a function definition. My brain, I can skip right past that. I don't need to know what that function does now. I can come back to it later when it matters for order of execution. So I'm going to jump down to line 13. That's the end of the function, and I see that the first line of code that's actually being run in this script is line 15, calling the parent function. Cool. Now I'm going to go up and look at what's on line 1. So I see that inside of parent, there's a couple things happening. Defining a variable, setting it to 0. I've got a function there. Functions inside of functions, totally cool. But it's defining a function, so I can skip over it for right now. So I'm going to go down, look at line 11. Okay, well now I need to go look at the function. Let's see what child does. Child is going to console.log x. And if I look in this function, I have to kind of look at the function as a whole thing all at once. And it's one of the reasons I like to do this example, because remember I said that our best practice is that we want to define our variables before we use them. Because if we don't do that, we get a situation like this. What would be better is if var x equals 8 was above the console.log, but it's not. JavaScript is going to know that that var x is going to be there. So x at this point is undefined. It hasn't been given a value yet. And I'm going to return x, which is going to bring me back down to line 11, but I'm not doing anything with that return value. I'm not saving it in a variable. I'm not catching it anywhere. It's just going to disappear into the ether. And then line 12, I'm going to console.log x, but I'm only able to log the x that parent knows about, which is this one right here. So I'm going to get undefined, because the variable exists, and 0. Let's watch it work. Or no. There we go. So examples like this are good practice because they put you in the position of having to think 10% less like a human and 10% more like a computer. You have to be able to understand the order in which JavaScript is going to execute this code. But let's look at a little bit more real-world example. So this is an exercise that you guys have today. It's your debugging number 3, I believe. And this is a legit script that does a thing. And we want to be able to understand what it does and why and how it works. And so, again, if I'm approaching this script as a dev, I've got a very particular goal in mind. I want to understand the order in which this script is going to run. And then if I look down here at the bottom, I see that there's a whole bunch of output. And there are things that I need to do in my head. For example, I know to anticipate looking at this code right here inside the console.log. Doesn't matter what that function does at that point. It literally does not matter what it does. I can read that and I know automatically that it's going to be one of two things of what's going to get console.logged. I'll give you a hint. One rhymes with T and starts with T and rhymes with blue. Starts with TR and rhymes with blue. True. True is one of them. And typically, anytime you see true, what do you see as the opposite of that? False. You guys will learn to be interactive. And the reason I know that is because I have left side triple equals right side. 100% of the time, unless the universe like takes a left turn, I'm going to get true or false back from that every single time. So I know automatically that lines 68 through 70 here are going to output either true or false. And if I know that, that's kind of cool because that means that if I'm calculating true or false and testing equality, and this is 61, then what can I guess about the return value of this function? Or a number. Ideally, it would be 61, yeah. If we, if we're testing that, that this is a true value that works. But yeah, I know that this is going to give me back a number. Because if I'm getting back a string, an array, an object, any other data type, triple equals is going to fail 100% of the time. Because there's a number on the other side. I can intuit these things and make these logical leaps, which is a good thing because it sets up expectations for how I'm going to go in and read the code that's inside that function. I now have an expectation of what that function is aiming for. And additionally, now that I know that this is probably going to give back a number like 61, calculate day in year. As a name of a function, it's not the most clear, but I can guess now what that day in year means. That's probably ordinally what day of the year, March 2nd, 1900 is. And for those of you doing the math at home, January has 31 days, February has 28 unless it's a leap year, and then add 2 more days. Well, that would be 59 plus 2 is 61. So it's probably going to be the 61st day. That's the most math I'm going to ask you to do today, by the way. Like, after that, we're good. And the thing is, now that I've done that mental math, if I look here at 2032 equals 62, well, that was 2000 a leap year. If you don't know the answer to that, that's okay. It was. And I can start looking at some of these other ones and recognize, oh, in fact, logically speaking, all of these should probably come back as true. If my function does what it's supposed to do, then it will do it. So I now have looked at this. I've made some assumptions. I have a better understanding of what this is going to do. And I can come up here and I can start to look at this code and start to address it. And I can start at the very beginning, line 1, calculate day and year. Okay, well, I've seen the name of this function before. I know that this is the function that does the stuff. Cool. I can skip all that. And one of the nice things is, especially like once you get comfortable with your editor, like Sublime, VS Code, whatever you're using, you can just jump to the corresponding closing parentheses. You don't have to worry about scrolling down and missing it. So I can just jump down and go, okay, well, here's another function, is multiple. I can make a guess about what that does based on the name of the function, but the first line of code that's actually being run is this. var date equals process.argv2. Cool. There are some things I know about this script based on that line. How am I going to run this script in order to get it to work? It's going to be command line, and I'm going to be passing something in on the command line. This script is expecting something on the command line. And I don't even have to read further down to this if condition to figure that out. Just by this line by itself, because it's pulling from process.argv, I know that when I run node space, whatever this script is called, it wants something else. And now I look down, line 49, if not date. So if this isn't defined, doesn't exist, then it's going to say console.log, please provide a date in the format year, month, day. Otherwise, run calculate day and year on that date. Pop quiz. What format, what data type is date at that point? I heard it. Whoever said it, be more bold. It was over here somewhere. Yes, thank you. Bravery wins. You can't see it today, but I actually have a tattoo on my arm that says, courage is deciding there's something more important than being scared. Be brave. The worst that's going to happen is I'm going to mock you openly. I mean, that's the worst that's going to happen. Come on. At best, I'll probably just be like, no. So yeah, date is going to be a string. Every time you pass in something on the command line, it's a string. So that means if I'm expecting this format to be a date, this is a string getting passed to this function. Before I even scroll up, I know that I'm going to have to convert that to a date probably. So let's scroll up and see what happens. Well, I'm splitting that string. Okay, good. My assumption was wrong. That's awesome. That means that I might have made that assumption down at the bottom, but now that I'm in this function, now we're going a different direction with it. Cool. So let's see what happens. We take the date and we split it on this, on slash. So, also in the annoying pop quiz department, what does split return? An array. Yes. Takes a string, breaks it on whatever character or characters you have given it, and returns an array every time. So I now know that in split date right here, I know that's an array. I can bookmark that in my head so that when I'm reading further down, I know that that's an array. We're going to take the first piece of that, turn it into a number, actually all three pieces. So year, month, day are all going to get set as variables by taking elements of that array and forcing them to be numbers instead of strings. And then here, I'm going to call a function called days in Feb, based on the year. Okay. So I don't see that function initially, so I'm going to keep scrolling down. Perfect. There we go. Days in Feb. Well, we're cheating. We're just assuming that it's 28 here. Okay, so Feb days is going to be 28. And then I'm setting up an array. Days in month. So, January, February, March, April, May, etc., etc., etc. I'm assuming you know how the months go. If you don't, talk to me after class. And now I'm going to start processing some code. So, if the year, when I'm saying if year, like if I just wrote the if statement, or, if parentheses year, what am I assuming about year at that point? Bobby, you look like you want to say something. True? Specifically true? But the variable says year. Am I going to expect a year value to be true or false? I know what it is, but what I'm asking is, in this particular case, is the year going to hold the value true or false, or is it going to hold something else? If I look up at line 3, I see that the year should be holding a number. So if I'm testing if year, what am I testing about that year? Not if it's a number. I know it's a number. I cast it to a number. There we go. So we have true and false, but we also have truthy and falsy. And our brain, fortunately, this is one of the areas where our brain is really good at dealing with that abstract concept. So year, in this case, I know it's a number, and I'm testing it for its truthiness. And if in JavaScript, numbers, almost all numbers are truthy. There's only one that is not. What is it? 0. So if this was year 0, then this wouldn't work. So I'm testing to make sure this is a truthy year. And then I'm calling a function here called valid month. That is this function right here, which I was able to gloss over before because I didn't care about it. So here's a case, again, where we have to think a little bit more like a computer. When I look at this expression, month and month is greater than or equal to 1, and month is less than 12. What's that going to return? True or false? Bingo, 100%. This is Boolean logic. So 100% of the time, this is going to return a true or a false. I've passed in my month value, which is a number. So I'm checking to see that it's greater, that it's not 0, that it's greater than or equal to 1, and that it's less than 12, because I want to make sure that it's a valid month in the calendar. I don't want somebody passing in like month 14 or something like that, you know, or month rutabaga. So this is going to return true or false. So here we have, if this is truthy, and this is truthy, and here we have valid day, month and day. So valid day is taking in two parameters. Checks the truthiness of the day, checks that day is greater than or equal to 1, and that day is less than the corresponding value in here. Why do we do month minus 1? Zero-based index. Two hardest things in programming: naming things, caching things, and off-by-1 errors. That gets funnier in about 3 weeks. Yeah, we have to account for the zero-based index. And once again, this is Boolean logic. This is going to return true or false. So truthiness, truthiness, and truthiness. So if all of this is true, then we're going to say this date is day, and we're going to run calculate day number. So basically, if all of this stuff is true, we'll actually calculate what the day is. And interestingly, we're calling the function twice, but that's okay. If it's not, we're going to say it's an invalid date. That's a good thing. That gives us some kind of negative output. One of the reasons I will tell you why line 13 is important is, as devs, as much as we are looking at how to read code and how to understand it, there's also a responsibility we have when we are writing it. So I'll tell you something terribly controversial. You're all taking this boot camp. Nobody's going to hire you to code when you come out. That's not what they're going to hire you for. You're going to learn how to code because you're going to need to do that as a career, but that's not what companies hire you to do. You get hired to build and support products. That's what makes revenue for companies. That's what pays your paycheck. So when we are building something like this, we have to think about what we are building as a product that's going to interact probably with a user. And if I just said, you know, if all this stuff, do the thing, and didn't give any other output, it would fail. I wouldn't get the output I expect, but I also wouldn't know why. This is my way of telling the user, hey, you put in an invalid date. So this is important in order to provide that full experience for whoever's running this code from the command line. So line 13 is important. And when I'm reading through this, I need to know, okay, well, that's an error. If things don't go in correctly, I should get this error. That sets my expectations so that if I go and run this script and I don't get what I expect back, I know what I did wrong. I've looked through the logic top to bottom. I see what's going on. So now we have this calculate day number function that we need to investigate. That's down here on line 24. And we're taking in month and day. We're saying that the day of year is 1, and we are running a for loop. We are starting at 1 and going for less than the month and incrementing each time. And we're going to keep saying day of year plus equals the number of days in the month with I minus 1, so that's accounting for the 0 index again. So we're going to keep adding up days of the year and return that. That's going to be the return value here. and we will run it again and return that. If I'm returning from the function, I'm automatically going to jump down to where it was called, which is here, and I'm not doing anything with that return value. But I can look at my tests and see that that return value is necessary because I need to compare it. Now, here's the fun part. We've talked through all of this. But one of the reasons this is debugging is that there are bugs in this code. But it's necessary to go through and be able to think through the logical leaps that each function has, each bit of Boolean logic has, so that you can start to understand. A lot of times we just call this rubber ducking. But in your brain, when you are approaching a new piece of code, you have to be able to walk through it that way and talk through logically what each piece of code is doing in order to be able to understand how to make changes, how to improve, how to refine, all of that. There are patterns that we are searching for. There will come a point, and I know this is early in the boot camp, and so me making this promise to you seems a little bit silly now, but I promise you there will be a point when you will start to look at this and you will stop reading the actual characters of the code and you will just see the bigger picture. It's not that far away either. I promise that day will come. For example, here we have a function, is leap year. Did we ever call that? No. This function is multiple. We didn't call that one either. So there's functions here that aren't even being used. That's an interesting point. For example, when we look at days in Feb, that's not always correct. There are not always 28 days in February. Sounds like a really good reason to use this function. And in fact, if I was reading this code and I was going to be addressing this, now might be the point where I do something like that. But that's a pattern that I can now recognize, and I can say, oh, you know what? Okay, that logically is going to work. I've logically solved the problem, but doing that is a lot cleaner. Same logic, just different syntax. And now, understanding that I have a function that tests is it a leap year, I can look at the logic in like is multiple. Okay. Is it a multiple of 400? Is it not a multiple of 100 and a multiple of year 4? I can trace through that math. And if I don't know how that math works, I can do the terrible thing of going to Google, how to calculate a leap year. Don't feel that you have to know all this stuff off by heart. That's why we have a Google. And right at the top, it gives me the formula. So if the year is evenly divisible by 4, go to step 2. Well, we've done that over here. If it's divisible by 4, okay. If the year is evenly divisible by 100, okay. Questionable. If the year is evenly divisible by 400, okay. So looking at what Google is telling us to do and this function, is it coded correctly? No, it's not. That was a hint, by the way. So yeah, now that we can follow through and trace out where these bugs might be, now we can start to have a better sense of where things are going wrong. Okay, so I've got 15 minutes left. and I'm going to give you some facts. Fact number one, which I already said. This is a fact. You use code to build features. Features benefit users. Users buy products with either money or time. Once they buy it, then you get paid. That's the cycle we live in. But if we think about what we're writing as only code, as just the logical bits and bytes and spitting out something to the command line, we stop thinking about it as being a product. Take care with your outputs. Take care with your inputs. Don't always assume that users are going to type in the right thing. You know, if you are someone who can honestly put up your hand and say that you have never made a typo in your life, especially when typing something as obvious as your name or your email address, well, congratulations. But if there is the chance that you might have made a typo, then you understand that people will too. And so that means part of our approach to code, part of what we're looking for in good code, whether it's from somebody else or from ourselves, is code that accommodates for that, code that behaves like a full product. My second fact I'm going to give you is I'm going to give you my secret to coding. And I'm going to tell you this, and it's a little bit tongue-in-cheek, but I'm going to explain why I say this, and I promise this will help you. Everything you're going to do with code, absolutely everything you're going to do comes down to one of these three tasks: logic, syntax, and data. And it's easy to remember them in that acronym, because if I tell you DSL, you start thinking about internet connections, and that takes you in a whole other direction. We actually deal with it in the order of DSL, but LSD is so much more fun to talk about. With data, it's this question. That's why I was harping on what data types were certain variables, what data type was going to come in from the command line. Because if I don't know what data type I'm working with, if I don't know if I even have the data, how can I write code around it? How can I write code to manipulate it or use it or print it out even? I have to have that data. And it's got to be in the format I expect, because otherwise I have to do something to make that happen. Syntax. Did I use the correct keywords and symbols? Code has a syntax because code is a language. That's the other reason I pointed out that that's been proven. Just the same way that when you go into Microsoft Word and you put in a phrase that doesn't grammatically evaluate and you get the little squiggles underneath it, or there's a typo and you get the red lines, your code editor is going to help you. And you know, that was probably talked about in yesterday afternoon's lecture. But your environment will help you, but also you are responsible for knowing what methods you're using, what they're going to return, and if it's a new method, well, you need to be able to go in and read what you explained to the computer to be able to do it. Here's an interesting fact. If programming is a language, then that means when we're coding, all we're doing is talking to the computer. And the really neat thing about that is it means that it's us having a conversation and explaining something that we already understand to the computer in a language that it can understand. The downside to that revelation is that it means that we have to be able to solve the problem first. If in human logic you can't figure out how to solve that problem, you have no hope of turning it into code. That's where pseudocode is such a big help. You know, if you go into a script like this, and down here at the bottom there are these comments like, hey, here are some simple tests. One of the reasons I was pushing you guys to understand that this was going to return true every time is because it says you'll know your code works correctly when all of these tests return true. But if you didn't read that part, you have to intuit it. You have to figure it out. Play Sherlock Holmes a little bit. So we have to know how to solve that problem. We have to have ideally started off with a set of comments, writing it down in a notebook, whiteboarding, like post-it notes, whatever it is that we're going to do to understand what that problem is and understand literally on a step-by-step level what it is we need to do in order to write that code, you know, in order to solve that problem. And then we translate that into the language the computer understands, in this case, JavaScript. So the syntax question is very easy as, did I use the correct keywords and symbols to communicate to the computer what I want it to do? And logic. Did I communicate to the computer a clear set of steps to solve the problem? Now, the reason I'm writing these three things as questions is because when you're debugging, when you're reading a new piece of code for the first time, you get to ask yourself versions of these questions in order to solve any problem that is on your screen in front of you. And it sounds minimalist. It sounds like, no, it can't be as simple as 3 little letters. But I can tell you, I've been using this for 20 years and it works. And here's the other really neat thing. The data doesn't change. Like, user's going to type in the data, or you're going to get it from a database, or from a file, or from an API. That doesn't matter in the code. The logic, you could be using Python, you could be using PHP, Ruby, Java, JavaScript, Erlang, Haskell, whatever. The logic doesn't change. The only thing that changes when you go from language to language is the syntax. From script to script to script, the only thing that might change is the syntax. The other two stay pretty constant. Because if I run this, if this script was written in Ruby, and I was running it from the command line and putting a date on the end to pass that into my script, the data hasn't changed. And the logic that I have to use to solve that problem hasn't changed one bit. The only thing that changes is the syntax. So this becomes a powerful method for you to both understand what a script is doing and to be able to fix any problems that may come up when you have to ask yourself, well, why is the date in February always returning as 28? It's not always 28. That's a bug. That's not logical. Well, that's a logic problem. No, we didn't communicate to the computer a clear set of steps. Okay, how do we do that? Well, how would I figure out if it should be 28 or 29? I'd need to figure out, is it a leap year? Like literally, if someone handed you an index card with a date written on it, and you had to by hand calculate what day of the year that was, what steps would you go through to do it? Forget the, even close the laptop for a minute and think about what would you have to write down on the back of that index card to make that happen. And then that translates into the set of steps that go into the code. And when you get to the point of figuring out whether it's a leap year, if you don't know how to guess whether it's a leap year or not, Google it. Syntax is entirely Googleable, and logic is as well. If you don't know how to figure out if something's a leap year, I'm sure someone's figured out that problem. So, hopefully this gives you a few truths that you can use and some techniques that you can use when you are approaching reading some code. Anybody have any questions? Crickets, tumbleweeds. Cool. So what I'll do is I will package this code out. I'll put these scripts into a gist and also these facts, and I'll send them off to you. Yeah, normally I'm around and mostly awake. So yeah, I'll just open the floor now for the rest of the cohort. Please feel free to bug me, like, anytime about anything. I'm on Slack, I'm on email. I'm very, very approachable. I couldn't be here for lecture this morning. So, great to meet you guys.